So this is an example that we'll be trying to solve today. So the question is something like this: consider the circuit shown in figure, which is redrawn in something. So this circuit is similar to this circuit. That is what is it telling. We wish to analyze the circuit to determine all node voltages and branch currents. We will assume that beta is specified to be 100. So it's a BJT math, and it's an NPN type BJT. You can easily see that. So it's an NPN type BJT. Okay, fine. So what we know so far, so this is base, this is collector, and this is emitter. So we know this voltage is positive 4 volts. Okay, that's good. And we know for a BJT to turn on, specifically an NPN BJT to turn on, VBE must be zero point 0.7. So now you can easily find out what's the value of VE. VBE is zero point 0.7, right? So VB must be then 3.3 volts, right? 3.3. So your VE becomes 3.3 volts. So these are the things we know so far. Now I know VE, right? So now let's assume. So recall in the previous lecture I told you guys to assume that the circuit will be in active region, and then do the math, and after we will verify whether it's in active region or not. This is the way we have to solve the BJT problems. Okay, so now let's try to do that. So assuming active region, assume active. So basically if we assume active region, then we'll be able to use the active region equation. So what equation can I use right now? Let's try to understand. So you can see that this is VE. I know VE, I know this resistance value, this is ground, so I can easily find the IE current. So IE equals 3.3k, sorry, 3.3 volts divided by 3.3k. So that means 1 milliamps. I is 1 milliamps. So right now I know 1 milliamps IE. So see that I'll be easily able to find what is IC, because IC is equals to alpha into IE. And now you may call that what is alpha then, right? Sorry, right, yes, alpha into IE. So if you recall properly, so alpha is something like this. Alpha is equals to beta divided by beta plus 1. That gives you exactly most probably 0.99. Okay, so now if you calculate this one, let me tell you, it will be, you can easily guess, 1 milliampere times 0.99 is 0.99 milliamps. It is simple math. So now, so what is the value of then IB? So it is also easy to find now. At this point you can easily subtract from IE minus IC. You just do this math, you just do this calculation here. So I'm having hard time writing C. So IE minus IC it would be, okay. So okay, I see. So it would be 0.01 milli. 1 milli. So see that I have found IE, I have found VB, VE. I need to find VC now. So what is the value of VC then? VC is, you can easily understand, this voltage here will be dropped across this to be this voltage, right? So VC is nothing but 10 minus IC times 4.7k. So IC is 0.99. So IC times 4.7. So 0.99 into 4.7. So it's 5.34. It's 5.34 volts. Okay, so I have found the values of all the nodes. That is V, the answer is VC, IE, IC, IB, VB, and VE, right? So these are the values I need to find. Now I have to check that whether my initial assumption of that the BJT is in the active region is correct or not. So in order to do that, I need to check what's the value of collector voltage is. It is 5.34 volt. See that 5.434 volt is actually greater than the base voltage, which indicates that it is indeed in active region. So our assumption is correct. Thank you.